momentum, well, we know that for this we have in a closed system, the momentum, if we can use P, is constant or is conserved. So B, now what we had in A actually provides a clue for B, how we're going to solve B. In an experiment, an air rifle pellet is fired into a block of modeling clay that rests, so that means it's zero velocity, on a table. So we have here the situation, and then it says the air rifle pellet remains inside the clay block after impact. As a result of the collision, the clay block slides along the table in a straight line and comes to rest. Further data relating to the experiment are given below. So we've got the mass of the pellet. Notice this is in grams, so that would be 0.002 kilograms, and this is 56 grams, so it's 0.056 kilograms. And the velocity of impact of the air rifle bullet is 140 meters per second, and the stopping distance is 2.8. Show that the initial speed of the clay block after the air rifle pellet strikes is 4.8 meters per second. So we're going to have a conservation of momentum as we had here. So your PB, your momentum before, is equal to your momentum afterwards. The momentum before is going to be the 140 meters, because remember momentum is given by mv, so it's going to be 140 meters per second times by the mass, which is 0.002, and that equals to the momentum afterwards, which will be the mass of the clay block plus the pellet. So that's going to be 0.2 plus 0.056, so it's 0.058 times by the velocity. So we're obviously going to just divide both sides by 0.058, and we'll get the velocity of the combined system. So we can do that here, put into brackets 140 times by 0.002, close brackets, divided by 0.058, and we get 4.827. So that's what we wanted to find. It's 4.8, so we get our velocity is equal to 4.83 meters per second to the negative 1. Then it says calculate the average frictional force that the surface of the table exerts on the clay block while the clay block is moving. So what's happening here is that the clay block starts off moving at 4.8 meters per second, and it comes to a halt, comes to a velocity of equal to 0 meters per second after a distance there of 2.8 meters. Now obviously we're going to be using our formula for the work. Now the total work that is being done. Now the kinetic energy at this point will be the energy, and that's all going to be lost. That work is going to be lost. So your EK, that starts off with, once it's the pellet has hit the clay block, is going to equal a half mv squared, and that's going to equal to the force times the distance, this Fs. So that's going to equal your force times the distance, which is equal to 2.8. So we're going to get a half times by 0.058 times by your v squared, which is 4.8 squared, is equal to the force times 2.8 meters. So we'll do that also on our calculators. So we got that 4.8. We're going to square that. We're going to times it by 0.058 times by 0.5. Enter. We get that value there, and we're going to divide that by 2.8. 0.8, and we get a force of 0.24 newtons would be the force that is being applied.